In this video, we're going to talk about how to set up equations using angle relationships. So let's take a look at this first example here. We have two lines that have intersected to create four angles. Now we know from the definition of vertical angles is that this angle and this angle are the same, as is this angle and this angle. Those are called vertical angles, and those angles are the same. But this angle relationship does not talk about two angles that are the same. This angle relationship talks about two angles that add up to 180 degrees. Because if you look at it, these two angles, if I put them together, would make a line, right? They would make 180 degrees. So all I have to do to find the value of s, like this question says, is plug in the two angles like this into this setup. This angle is angle 1 and this angle is angle 2. Doesn't really matter. You could switch them if you wanted. But the important thing is that the two angles combine to be 180. So now let's combine like terms. 3s and 2s makes 5s. And 6 and negative 1 would make positive 5. And this adds up to 180. So when we're all done with this problem, we're going to end up with s equals a number. So to get to that point, we need to use inverse operations. Let's do minus 5 to both sides and get 5s is equal to 175. And then if I want this 5s to, if I want to just be s, I need to divide both sides by 5. And 175 divided by 5 is 35. So that means s in this problem is 35. Now if this question wanted you to find the measure of this angle, all you would have to do is plug 35 in where it says s. So I would do 3s plus 6, or 3 times 35 plus 6. 3 times 35 is 105, plus 6 would be 111 degrees. This angle would be 111 degrees, and so would this angle because they're vertical. Now while we're here, we might as well plug in this one. 35 times 2 is 70, minus 1. 69 degrees. This one would also be 69 degrees. A couple ways you could check this. These two angles should add up to 180. These two angles should add up to 180. These two and these two. Those all four angles pairs there should add up to 180. Or all four angles all together would make a complete circle, right? So all four angles should add up to 360 degrees. And if I double check really quickly, do some mental math, it does add up to 360. So that's how I know my answer is correct. So let's move on to another example here. And what we're going to have here is an example where the this time the angles are vertical, right? This angle and this angle are the same. So these two angles do not add up to 180. And when I set up my equation, I should not say that angle 1 is plus angle 2 is equal to 180. Rather, for this angle, if I want to find the value of q for both of these angles, what I'm going to need to do is say that angle 1 is equal to angle 2. So I need to say that 4q plus 12 is equal to 8q minus 20. And I can say that because they're vertical angles, and vertical angles are always the same. They're always congruent. So now how do we solve an equation when there's variables on both sides? This might be new to you in 8th grade, but that's okay. We'll get you through it. To solve an equation when there's variables on both sides, your first goal should be to get all the variables on one side. It doesn't matter whether you decide it's the left or the right. You should get all the variables onto one side by using inverse operations. Now, if I want to move just this 4, I would divide everything by 4. But I don't want to move just the 4. I want to move the 4 and the q. This whole 4q here is a positive, and it's being added on this side of the problem. So if I want to pick this up and move it to the other side, I'm going to do minus 4q, and I'm going to do it to both sides. That'll make it go away, right? Because 4q minus 4q would cancel, and I'd be left with 12 equals 8q minus 4q minus 20. Well, I would combine like terms there and get 4q. Still bring down the minus 20. And now we have our typical equation setup. Now that we just have one variable on one side, let's do what we normally do. Let's use inverse operations to get the q by itself. So when we're all done in this problem, we're going to see that q equals Q equals something, right? So let's use inverse operations. Let's do plus 20 to both sides. Cancels that out, and we get 4Q equals 32. Then the last step here would be to divide both sides by 4, and we'd get 32 divided by 4. Q is equal to 8. Now, just like the last problem, this question says solve for the value of Q, and I've done that, so I'm technically done. But sometimes these questions might instead say find the measure of each angle, or find the measure of one of the angles. So just in case a question does do that someday, I'm going to practice that right now. If 8 really is the value of Q, then I should be able to put 8 in right here. So 4 times 8 plus 12. 4 times 8 is 32 plus 12. This angle is equal to 44 degrees. This angle is equal to 44 degrees. And guess what? Because these angles are vertical, this one's also equal to 44 degrees. And I'm going to quickly double check that. 8 times 8 minus 20, which is 64 minus 20, which is 44. So that checks out. Both those angles are 44. Now, if for some reason they ask me for these angles, well, these two angles are supplementary. These two combine to be 180. So I would just need to do 180 minus 44 to get this one. And 180 minus 44 is 124, or 26, I'm sorry. Sorry, 136. There we go. 136. And this one's also 136. There we go. That's how you do that question. We'll do one more example. One more example where the angles are vertical. So this one says solve to find the value of B. So these two angles are vertical, right? So this angle and this angle are congruent. That means that they are equal to each other. So 9b minus 7 equals 8b plus 6. So when I'm all done with this problem, I should get way down here, b equals a number. So remember, I said if you ever get an equation where there's variables on both sides, you should start by getting all the variables onto one side. It doesn't matter which side you do. What I'm going to do as a habit, as a way to make things easier, is I'm always going to take the smaller variable term, the term with the smaller coefficient in front of it, and I'm always going to move that to the other side. And the reasoning for that is if I always move the smaller variable term, then I will always be taking a big quantity. A big quantity will be be subtracted by a smaller quantity, right? So if I do minus 8b here to both sides, I'm going to definitely end up with a positive here, right? 9b minus 8b is 1b. If I were to do it the other way, I would still get the same answer in the end, but I would end up with a negative here. And I like to avoid negatives when possible. All right, so the first thing I did was I moved the 8b over to this side by using inverse operations. The opposite of having 8b over here is doing minus 8b to both sides. And 9b minus 8b is 1b. And the negative 7 and the positive 6 get brought down. Now, most of the time when I do this, I'm not going to write that 1. In fact, I'll write it right here. b minus 7 equals 6. When there's a coefficient of 1 in front of a variable, you don't have to write the coefficient. So it looks like we just have one more step here to get the answer, and that's to do plus 7 to both sides, and we're going to get b equals 13. Now, again, this question is asking for the b, so we are done here, right? But just to be safe, just to show you how this is done, I'm going to put b is 13 in here. I'm going to do 9 times 13 minus 7. And 9 times 13 minus 7 is 110 degrees. This one's also going to be 110. And I'll double check that because 8 times 13 plus 6. 8 times 13 plus 6 is 110. And that makes this one 70 because these two have to add up to 180. And this one also 70. So there we go. There's the 4 angles of this problem. That's all for today. Thank you for watching.